Factor n squared minus 6n minus 9. This is not either of the special forms that we had seen before, because this last term is being subtracted. So it's not a perfect trinomial square. With the perfect trinomial square formulas, the first term had to be positive and the last term had to be positive. Now that doesn't mean that we conclude right off the bat that it's prime. These formulas for perfect trinomial squares were just shortcuts for us to help us unfoil or use the AC method on things. So we still want to make sure that this isn't something that could be factored another way. So if we look at this, this is a trinomial with a leading coefficient of 1. So we can attempt to use the unfoiling method. We would have n plus or minus one number times n plus or minus another number. And so for the constant terms, we're looking for two numbers that have a product of -9 and a sum of -6. Well, -9 is -1 times 9. It's -3 times 3, and it's -9 times 1. If we look at the sums of each of these pairs of numbers, -1 plus 9 is 8, -3 plus 3 is 0, and -9 plus 1 is -8. We cannot find two integers that have a product of -9 and also a sum of -6. So now, because we know that those numbers don't exist, we are able to conclude that it's prime. But we could only make that conclusion when all of the factoring methods that we've learned have failed. There's no GCF. We can't use unfoiling. We wouldn't use the AC method here because there's no leading coefficient. We wouldn't use grouping because there's only 3 terms instead of 4. So all of the things that we know have failed. Therefore, we will conclude that it is prime.